Picture a machine on a construction site. It can spin in a perfect circle. It can pivot inside a space barely wider than itself. It can turn faster than most cars, without moving forward at all. And it has no steering wheel. Not broken, not missing. It was never designed to have one. And the first time you hear that, your brain does something interesting. It tries to fix the problem. Maybe there's a hidden mechanism. Maybe the wheels turn underneath. Maybe a computer is doing the steering. But none of that is true. The wheels never turn. Not a few degrees, not slightly. They are locked straight. And yet, the machine goes exactly where the operator wants. That's the part that should bother you, because everything you think you know about steering says that shouldn't be possible. Let's start with the instinct you already have, because it's not wrong. It's just trained on the wrong machine. Every vehicle you've ever used works the same way. Car, bicycle, truck. You turn the wheels, the vehicle follows. That idea is so universal it feels like physics. Turning means changing the direction of the wheels. Simple. So when you see a skid steer loader spinning on a job site, your brain doesn't question it. It assumes something is turning. Hidden linkage, internal pivot, something you can't see. Because the alternative, that the wheels never turn at all, doesn't even register as possible. So let's break that, because what's actually happening looks completely different up close. The wheels on the left side and the right side are not connected at all. They're powered separately, two independent systems, two independent flows of force. Now watch what happens. Both sides push forward. The machine moves straight. But the moment one side slows down, you can see it. The faster side keeps driving. The slower side starts to drag, and the entire machine begins to rotate. Not because anything turned, because something stopped keeping up. And this is where your intuition slips again. You hear independent control, and it sounds unstable, like you'd constantly be overcorrecting, like the machine would jerk left and right every time you touched the controls. And honestly, that sounds reasonable. If this were just on and off, it would be uncontrollable. Full power, no power, nothing in between. You'd be fighting it every second. But that's not how this works. This system isn't binary. It's hydraulic, which means you're not switching, you're modulating. You're controlling flow. You're deciding moment by moment exactly how much force goes to each side. Left side at 90%, right side at 100%. The machine drifts. Push the difference further, it turns. Push it all the way, it spins. Not violently, not unpredictably, precisely. Because you're not steering direction, you're sculpting force. Now here's where it gets uncomfortable, because this breaks a deeper assumption. You might think, okay, fine, it works for small machines, but real vehicles need proper steering, angles, geometry, precision. That's what keeps things stable. And that's true, at speed, because steering geometry solves a very specific problem. How to let wheels roll smoothly through a curve without tearing themselves apart. That's a high-speed problem. This machine doesn't care about that, because it's not trying to roll cleanly. It's doing something much more aggressive. Watch the tires. They don't follow a curve. They don't align into a smooth arc. They scrape. You can actually see it. The rubber gets dragged sideways across the ground, not rolling, sliding, folding, gripping, letting go. The ground isn't guiding the machine is forcing the ground to give way. That's the mechanism, not steering, friction. And once you see that, everything clicks into place. Because now, we can push it to the extreme. Left side, full forward. Right side, full reverse. Same power, opposite directions. And suddenly, there's no forward motion at all. No backward motion. Just rotation. The machine spins in place, perfectly centered. No turning radius, no arc, just pure rotation. And you can feel it when it happens. The entire body pivots like it's anchored to a point beneath it. The tires grind, the frame twists, and in a single motion, it's facing the opposite direction. Done. No three-point turn, no adjustment, just spin. Now here's the trade, because nothing like this comes for free. Every time that machine turns, those tires are being dragged across the surface. That's friction. That's heat. That's wear. You're literally grinding rubber away every time you change direction. On dirt? Fine. On gravel? Acceptable. On concrete at speed? You'd destroy the tires in weeks. And at high speed, it gets worse, because now the wheels need to roll cleanly, not skid. And the moment they stop rolling cleanly, you lose stability. So this system isn't better. It's specialized. It trades efficiency for control. It sacrifices smooth motion for absolute maneuverability. And in the environment it was built for, tight spaces, rough ground, low speed, it wins completely. So now go back to the original question. A machine with no steering wheel, no turning wheels, no steering geometry. What's actually happening? Two independent flows of force, left side, right side. And the difference between them, that imbalance, is everything. More difference, sharper turn. Opposite directions, instant spin. Equal force, perfectly straight. There is no direction being set, only force being distributed. And that's the shift. Because the entire time, you've been thinking about steering as a question of where the wheels point. But here, nothing points anywhere. Nothing turns, nothing aligns. The machine doesn't follow a direction, it obeys an imbalance. And once you see that, really see it, you realize something unsettling. Steering was never about direction. It was always about force. You just never noticed.